the last lecture we have solved two problems from the series combination of resistors. In today's session, we are going to solve few problems from the parallel combination of resistors. First, we can start with an example given in your textbook. Example 12.9. If in figure 12.12, R1 equal to 10 ohm, R2 equal to 40 ohm, R3 equal to 30 ohm, R4 equal to 20 ohm, R5 equal to 60 ohm, and a 12 volt battery is connected to the arrangement. Calculate. The first question is the total resistance in the circuit, and the second one is the total current flowing in the circuit. First, we have to calculate the total resistance of the circuit. Here, I am just redrawing the resistance along in order to find the total resistance. R1 and R2. Here, R1 and R2 are parallel. And again, I am breaking the circuit from here and arranging them lengthwise. So here three resistors are there. So if I break the circuit, then we will get the shape like this: R1, R2 and parallel, and R3, R4 and R5 are parallel. So I am going to, in order to get the total resistance, I am just rearranging the circuit and replacing the circuit in another way. See, here R1 and R2 are parallel. Then the total resistance, the equivalent resistance of R1 and R2 can be represented by Ra. And here three resistors are there, and all these resistors are in parallel. So I will replace this equivalent resistance of these three resistors into one. It will be represented by Rb. So it will be equal to Rn and Rb. See, Ra and Rb. Here, Ra means the equivalent resistance of R1 and R2. We can use the equation to find the total resistance or equivalent resistance when two resistors are connected in parallel. That will be equal to 1 by Ra. It is represented by Ra. 1 by Ra equal to 1 by R1 plus 1 by R2. Similarly, we can replace the equivalent resistance or the total resistance of R3, R4 and R5 by Rb. So it is represented by Rb. So you can replace this R1 and R2 by Ra. That is the total resistance of R1 and R2 when connected in parallel. And it will be in series with the total resistance of R3, R4 and R5. It will be replaced by Rb. So we can summarize this circuit in the form of Ra and Rb. First, we have to calculate Ra by using the parallel equation. Then Rb. Then we will use the series combination of Ra and Rb. So I will explain again. Here R1 and R2 are parallel, R3, R4 and R5 are also parallel. But these parallel combination, here we will get a total resistance. It is represented by Rn. Here also there will be a total or equivalent resistance. It is represented by Rb. The equivalent resistance of R1 and R2 is in series with the equivalent resistance of R3, R4 and R5. That is replaced by Ra and Rb. Here you can see Ra in series with Rb. That means the equivalent resistance of R1 and R2 is in series with the equivalent resistance of R2, R3 and R5. Now we can find Ra. What do you mean by Ra? Ra is the equivalent resistance of R1 and R2. So 1 by Ra. What is the equation to find the parallel? That is 1 by R equal to 1 by R1 plus 1 by R2. So here the total resistance is represented by Ra for R1 and R2. 1 by Ra equal to 1 by R1 plus 1 by R2. Now substitute the values. What is R1? R1 equal to 10. 1 by 10 plus 1 by 40. Then we will get, and we can take the LCM. Then it will be like 4 by 40 plus 1 by 40. That's equal to 5 by 40. Now we got 1 by Ra equal to 5 by 40. Isn't it? 1 by Ra equal to 5 by 40. In order to find Ra, we have to take the reciprocal of this one. Implies Ra equal to 40 by 5. Always I will write, if you have confusion, 1 by Ra equal to 5 by 40. Therefore, Ra equal to reverse, that is reciprocal of this one, 40 divided by 5. What is 40 by 5? That's equal to 8 ohm. So we got RA. Similarly, we can calculate RB. 1 by RB equal to, here 3 resistors are there. So we have to write the equation for finding the equivalent resistance when 3 resistors are connected in parallel. That will be equal to 1 by first resistance R3. 1 by R3 plus 1 by R4 plus 1 by R5. Now substitute the values. R3 1 by 30. 1 by 30 plus 1 by 20 plus 1 by 60. Here the LCM will be 60. So we have to make this 30 into 60. That is 2 into 30 equal to 60. Similarly here we have to multiply with 3. 3 into 20 equal to 60. So we can write 2 by 60 plus here 3 we have to multiply by 3. 3 by 20 plus 1 by, sorry, here also 60. LCM 60, then 6 by 60. So we got 1 by RB equal to 6 by 60. Therefore RB equal to reciprocal of this is 1 by RB. 1 by RB equal to 6 by 60. So what will be RB? RB equal to reverse of this one. 60 by 6. That's equal to 10 ohm. Now we got the values for RA and RB. Here RA and RB are in series. So we have to use the equation to find the total resistance of the circuit. So what is the total resistance of the circuit? That will be series combination of RA and RB. First answer is therefore the total resistance. The total resistance here you need not use the equation to find the parallel resistance. The reason is here RA and RB, that is the equivalent resistance of two parallel combinations, are in series. So you have to use the equation of series combination. So the total resistance, it is represented by R equal to RA plus RB. Substitute the values. RA was 8 ohm plus RB 10 ohm. So our total resistance for this circuit is 18 ohm. Is it clear? That is how to calculate the total resistance. Here two combinations are there. These are parallel. Here this one is parallel. R1 and R2 parallel. R2 are parallel. But these two parallel combinations are in series. When you break the circuit, you can arrange these in a single line. Here I just break here and I can arrange this one lengthwise. So you can see that the equivalent resistance of these two parallel combinations are in series like this. So we got the total resistance. Now there is one more problem, that is the second one. We have to calculate the total current. So what is the total resistance? Total resistance we got as 18 ohm and total potential difference is given, that is 12 ohm equal to 12 volt, so 1 ohm, 12 volt. Now we can calculate the total current. The total current in the circuit, it is represented by I. And now you can apply the Ohm's law. I equal to V by R. Substitute the values. V equal to 12 and R equal to 18. 12 volt and 18 ohm. So our answer will be 0.67 ampere. Now we got the total current flowing through the circuit as 0.67 ampere and the total resistance of circuit as 18 ohm. Now we can move to the textbook exercises, page number 216. Some of the questions are given. Before going to solve the problems related to the parallel, I will give you some tips. Suppose 3 resistors, 1 ohm, 2 ohm, 3 ohm. You can join all these resistors in parallel as well as in series. If you want to get the total maximum resistance that can be obtained by connecting all these 3 resistors, you have to connect in series. If you want to decrease the resistance, decrease the total resistor, you have to connect in parallel. So if you are connecting all these resistors in series, your answer will be maximum. So actually we are adding the individual resistances. So our answer will be, you can simply judge the total resistance when these three resistors are connected in parallel. A series will be some, then it will be obviously it will be larger than the largest individual resistance. Which is the largest individual resistance in among these? The largest number is 3 ohm. The total resistance will be more than the largest resistor, that is more than 3. And if you are connecting these resistors in parallel, any example, then the total resistance will be less than the smallest. If you are connecting the same resistors in parallel, the equivalent resistance will be smaller than the smallest value, which is the smallest value. So our question is, judge the equivalent resistance when the following are connected in parallel. Here you need not to solve the problem. You have to judge what will be the answer. So the first one is 1 ohm and 10 raised to 6 ohm. Here we have to calculate, you have to judge the total resistance when these two are connected in parallel. I told you from the beginning, if you are connecting few resistors in parallel, the total resistance or equivalent resistance will be smaller than 1, smaller than the smallest number. Here 1 ohm is smaller than 10 raised to 6 ohm. So in this case, if you are connecting 1 ohm and 10 raised to 6 ohm in parallel, the total resistance will be less than 1 ohm, because 1 ohm is smaller than 10 raised to 6. And similarly, you can easily judge the total resistance when you are connecting 1 ohm, 10 raised to 3 ohm and 10 raised to 6 ohm resistors in parallel. Then which is the smallest value here? 1 ohm, isn't it? So our answer will be the total resistance when these three resistors are connected in parallel will be always less than the smallest value, that is 1 ohm. So we have solved the problem. In the next question, an electric lamp of 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much as current as all three appliances, and what is the current through it? In this problem, three resistors are there. The first one is electric lamp, the second one is toaster, and the third one is filter. So before solve the problem, better you draw the circuit diagram. So I have drawn the diagram like this: R1, R2, R3. These represent the lamp, toaster, and filter. All these are connected in parallel with the 220 volt battery or source. And in this question, they mentioned that the resistance of these, the total resistance of these three, are equivalent to the resistance offered by the electric iron. So I have drawn one more circuit that the entire equivalent resistance of these three appliances are equal to the total resistance provided by the electric iron. So our question is to find the resistance of the iron as well as the total current flowing through the circuit, otherwise the total current drawn by the electric iron. Let's see. First we have to find the resistance of the electric iron. Resistance of the electric. This resistance of the electric iron, it is represented by 1 by R, that is the total resistance. That will be equal to the resistance of the parallel combination of these three appliances. So 1 by R will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the values: 1 by 100 plus 1 by 50 plus 1 by 500. So what will be the LCM? 1 by R equal to 5 plus 10 plus 1 divided by 500, isn't it? 5 into 100, that will be 500. 10 into 50 equal to 500, and 1 into 500. So our answer will be 16 divided by 500. This is not our answer. This is 1 by R. So R will be the total resistance offered by the iron or the total resistance of the circuit. Anyway, they will ask the question. Here the total resistance will be the reciprocal of this one. That is 500 divided by 16. That is 1 by R equal to 16 by 500. So R equal to 500 by 16. So our answer is 31.25 ohm. Now we have solved for the first one. Then we have to find the current, also the total current. So therefore, current, we have the equations R equal to, we have the values R equal to 31.25 ohm and potential difference V equal to 220 volt. Now we can calculate the current. The total, this total current will be equal to the current drawn by the electric current. So I equal to, what is the equation? Apply the Ohm's law, V by R. I equal to V by R. Substitute the values, that is 220 volt divided by resistance 31.25 ohm. We can remove the decimal from here, a point from here, then 220. Here 2 bits are there, so you have to multiply the numerator and denominator by 100. 2 bits are there, then divided by 31.25. Then simplify, cut out with 5, then you will get the answer like 7.04 ampere. So answer is 7.04 ampere.